Hello everyone, welcome to Technocraft. This is the third module of the course Python for Beginners. If you have not gone through the previous modules, I encourage you to watch the previous modules to have the continuity. Alright, what we will cover in this module, we will go through the list, then we will see for loops, and we will see how to use break and continue in the loops, and finally we will see the while loop. Until now, if we wanted to declare a string or an integer variable, we would type a code such as x is equal to 5 or instruction name is equal to Python PO. Our variable now have a specific type or object. In this case, we have an integer or a string, but sometimes we want to hold multiple objects under one variable. That's where the list comes into play. Let's take an example. Student underscore name is going to contain a list of students enrolled in this course. So under variable name we can have Mark, Katrina, Jessica and so on. This is where the power of list in Python comes in. Let's start to define a list in Python. What you do is write a variable name. So let's take our student underscore names example and assign it empty square bracket. There you have just created an empty Python list. However, let's say we already know some of the students enrolled in this course and we want to create our students underscore name list with their names already in it. In that case, we simply replace our empty brackets with Mark, Katrina and Jessica. Now our list has three string elements. Notice how they all have their own enclosing quotes because they are string and how they are separated by a comma. In order to access an element in a list, we use something called an index. An index is an integer value string from 0 which correspond to 1 and just one element in the list. For our list, if we wrote a code such as students underscore name raises 0, we would get Mark. If we wrote code names such as students underscore name raises 2, we would get Jessica. The important note here is that the list indices in Python start with 0. So even though we have Mark as our first element, the index is 0. The next element, Katrina, which is our second element in the list, has an index of 1 and so on. Now, if we wanted to get the last element in our list, we can write something like students underscore name raises -1. This is going to have the first element from the right side of the list, or in our case, Jessica. Here, the indices do start with 1, though it's a bit confusing, but just remember there is no such thing as 0. Replacing an element in the list is also easy as checking for a specific list of elements. So let's say students underscore name raises 0 equal to James. If we now print student underscore name, we see that Mark is gone and that James took his place. But let's say that we already have an empty list or a list of 3 students. It doesn't really matter, and we wanted to add more students to our list. As our code executes, we can do students underscore name raises 3 equal to Homer. But what we can do is use a function in our list called append. We can pass any object we want to the append function as its argument. Once we do that, the object we have passed through the append is added at the end of our existing list. Obviously, sometimes we want to check and see if we already have an element in the list. Is Mark still in it or not? Well, if you know English, you know Python, because this is as simple as Mark in quotes in students underscore names. If the Mark element is in the list, This will give us true. If it is not, it will give us false. Many times, though, you want to see how many elements you have in a list by simply using the Python built-in function called len and passing it our list as an argument. We'll get an integer telling us how many elements we have in our list. The len is short for length, and it can be used for other type as well. Like len of a string, we will count the number of characters in a string. Lists in Python are very similar to arrays in many other languages, but they come with some added benefits. Like what? Notice how, as is usual with Python, we never told our program that our list is a list of string. We just started typing strings. For that reason, we are completely free to add a number, such as an integer or a none or a boolean or any other type to our existing student underscore name list. Python is not going to complain. Having multiple types in a single list is just fine, although in my experience, it's best if you restrict your use of a list to a single type just to minimize potential bugs. Now, you may be wondering if you can just use none in the same list or an empty string or whatever. Then how do you delete an element from a list? Let's say I just want Jessica on the list. I just don't want Jessica on the list anymore at all. Good question. If we just did something like student underscore name raises 2 equal to none, we will remove Jessica, right? But our list size would not shrink. Simply none would replace Jessica. If you wanted to get rid of that, we have to write something like this. Del students underscore name raises 2. So the Jessica will get replaced and she is no longer available in the list. And something to notice, the del comes without a parenthesis. Note that the list is going to shift to the left after this operation. So whatever elements we have kind of to the right of Jessica, which is just Homer in our case, they are going to get moved one position in the left, meaning that student underscore name raises 2 is now going to refer Homer and not Jessica. List slicing. Another nice thing we have in Python is called list slicing. Let's say we wanted to ignore the first element of our list, mark, and get all other ones. What we can do is write student names on the braces 1 colon. This keeps the first element of our list and simply give us the rest of them. Now remember how earlier we said that we can use negative indices to get the last element in our list. Similarly, here we can use something like this. So if you write student underscore names braces 1 colon minus 1, we have just ignored our first and our last element in the list and printed the rest of them. Note how this does not modify the list. The list will still stay the same. It's just that we are temporarily ignoring certain elements. For example, when printing. Of course, I just went through the basics of Python lists in this video. Believe it or not, there are many other parts of the list, methods such as pop, reverse, etc. But the true part of list in Python comes with something called list comprehension. For now, let's see how we can print every individual element in our list using loops. Printing the list elements. Earlier, we saw that one way we can use or print single element in our list is by referring to the list itself and then adding as index using square brackets at the end of the list. But what if we wanted to print every element in our list? Sure, we could do something like this. But this become very ugly very fast. Let's say we have 50 elements in our list. Are we going to call the print function every time? No, we shouldn't really repeat ourselves. This is where loops can be extremely helpful. Loops in Python allow us to go through a list or something called an iterable object and repeat a certain block of code that we define for every element in our list. There are two main loops in Python, for loop and while loop. Let's take a look at the for loop. A for loop is probably the one you are going to use more often. So let's start with that only. This is what typical for loops look like in Python. Running the code is going to print the name of every student in our student underscore names, or in other words, every element in our list. This name variable we introduced refer to the single element in our list, in our case name, which is why we call it that. You can read this code as for every name in the students underscore name list. Do this. Every time our code goes through a for loop, we call it an iteration. Once all the names has been printed, that is once all the list elements have been used, the loop finishes and the rest of the code outside that for loop block executes. If you have encountered for loops in other programming languages, it usually looks something similar to this. In other code example, we are defining a starting point which is usually 0 because it normally get used as an array index inside for loop. Then we tell it how many iterations to perform, which is usually the length of an array minus 1, and an increment which basically tells our loops what to do with our index we defined once an iteration finishes. Normally we want to increase it by 1 so that we can access the next element in our array. However, this doesn't look close to our Python for loop at all. Now you may be surprised to find out that this does the same thing as our Python code. Python as usual hides something away from us a little bit, so when it detects that you are iteration over a list, it automatically assumes that you wanted to start from the first element in the list and that you wanted to increment by 1 every time the loop finishes, and it detects the length of the list as well, so it knows when to stop. Python for loop in case work like a for each in other languages, but Python does not have a for each. It will just do that for you automatically when it detects that you are iterating over a list. But what if you do what numbers like a straight point and a step and all that? Don't worry, that's where the Python range function comes in. Let's actually jump into a Pycharm and see what kind of result we will get. Suppose you have a piece of code that you wanted to be printed 10 times on the screen. You don't have a list defined anywhere. You don't care for it. In fact, you don't like a list at all. That's fine. Let's see how we can use a for loop in that case. Let's take a look at the code. So here's the code. So we have a variable x defined as which is set to 0, and then start for the for loop and uses this range function which we'll explain in just 1 second. Every time we have an iteration, I want to increase the value of x by 10. This can be written also like x is equal to x plus 10. Then I want to print the value of x here. Now let's execute and see what happens. Once we enter for the loop, the x value gets increased by 10. So the first result is the value of x is 10 all the way to 100. But what does this range function do? Well, it basically takes whatever number you passed it and kind of convert it into a list. In our case, that will be a list that looks something like this, it would go on all the way to number 9, which what essentially think of the number as the number of iterations, or how many times you want you for the loop to execute. We pass it 10, so we want our for loop to execute 10 times. In this case, the index values we defined will be the element of the list. So first it's going to be 0, then 1, 2 and till 9. But what if I wanted to the list to start from 0? I'm going to use the index for my loops somewhere, but I don't want to start from 0. Well, I'm glad you asked. Range function also supports 2 arguments, so you can call it like this: range, then on the braces 5, 10. In that case, our list is going to look something like this, which starts from 5, 6, 7, 8 and end up in 9 or 10. But wait, what if not only I don't want to start it from 5, but I also wanted to increment by 2 every time, not by 1. Again, range function also support 3 arguments, where the last argument is the increment. So here you would have something like this: range braces 5, 10, 2, and your list will look something like this: 5, 7 and 9. Once the loop for loop finishes, whether we are iterating through the list or using range, it doesn't matter. We will exit the for loop block and continue executing any code we have defined afterwards. But what if I wanted to exit the for loop before it finishes? Or what if I don't really want just this one iteration to execute? What I do want to execute the other one? Can I do that? Of course, you can do that by using break and continue. In some cases, we just don't want for the loop to keep executing itself until it runs out of elements in a list. Let's assume that we are searching for some string in the giant list of strings. So we are iterating over the list, trying to see if it's there and then do something with that string. Well, once we find it, there is no point in keeping the loop alive, right? We already found our beautiful string. That's where the break keyword can be very helpful. Simply putting the break keyword will cause our loop to stop, execute and exit without reaching the end of the list or the end of the range function. To demonstrate this behavior, I'll again go back to our Pycharm. We are back with our lovely students underscore name example, but I have a little more additional names here. To demonstrate this behavior, I will again up Pycharm. We are back with our lovely students underscore name example. Except in this case, I have expanded the list to include some more names, and I have a for loop that's simply testing to see if the name is Mark. You see it here, and if so, it just says found him and prints his name. Otherwise, it just prints currently testing and then the names or every element in the list. Now to execute this code, we just how to go here, right click and execute. So the result is on the bottom. So we just see we found for mark for sure, but we also see that the loop keeps on going and it also tests both Frank Grimes and max powers to see if they are mark, which they are not. So normally we don't really need to test it either. The only thing we need to do is add the break keyword. I'm going to add the break right after the print statement. Alright, so we have the break statement and now I'm going to execute it again. You see, this is not like the previous time. It's found mark and it stopped executing after it found the mark. This may not seems like much, but imagine if you had thousands of elements in your list and the elements you are looking for is in the second position, you can and should save valuable processing power simply by breaking out of the list. That's great. Now let's say that we want our for loop to execute for every element in our list except for mark. When it reaches mark, we just don't want our loop to execute any of its code, but we do want the for loop to continue and execute its code for Frankie and max power, which comes after mark in the list. How do we do that? Simply by using the continue keyword. First thing, I'm going to get rid of the break keyword which we added earlier, and I'm going to add the continue keyword here, and then let's execute the scripts again. You see what happened here? It skipped the execution for mark and continued with other executions. That's because by using a continue keyword, we tell our list to skip executing the rest of its code and just proceed or continue into the next iteration directly. So everything below the continue keyword will not be executed. Now Python doesn't just support for loops. It has while loops as well. Let's see what similarities and differences there are between the for and the while loops. While loops. If you understand for loops, you will understand while loop just fine. While loops looks very similar to for loops. Also have break and continue, and the whole point is for the code to repeat itself while come condition is true. Now this is what a while loop look like in Python. One difference that you can notice from the for loop is, other than the obvious use of while, that we have to manually increment our index of x value, in this case at end of our while loop. X is equal to x plus 1 in our case. While loops are useful because they check for a condition before they even enter the loop. Here we have the x is less than 10 condition, but if we modify the x somewhere else in our code and made it 20 before the loop, our while loop would not execute at all. Similarly, in our current code, once x becomes 10, the while loop will exit. One usage of while loop, although probably not always a great idea, is writing a piece of code that something you see on the screen. This is going to call something called an infinite loop, since true is always true, meaning since our condition is always passing, this while loop will keep executing forever. How do we get out of it? By using the break keyword, just like in for loops, or by modifying the condition like changing the value of number in some other part of our code. The while true or other ways of infinite loops can be useful when you want to keep repeating a certain code all the time until something happens, at which point you would change the value of number above. Enough about the loops. Now we will take a look at one of my favorite part of Python, that is Python dictionary, in the next module. Thanks for watching.